Hello, today we're going to start a new chapter, chapter 6, integration. In previous chapters, we discussed the differentiation. Integration is just the opposite operation of differentiation. So we can use the rules for differentiation backwards when we take integration. Let's start from 6.1, antidotes and the rules of integration. We define antidotes and the indefinite integral first. A function capital F is an antidote of small f on the interval I if capital F prime equals small f for all x in I. In other words, small f is the derivative of capital F, but at the same time, you can also call capital F an antidote of small f. An antidote is not unique. If you add a constant to capital F and take the derivative of that, you still get small f. So you get a family of functions of antiderivatives. And we call this family of functions given by capital F plus c the indefinite integral of small f, and is denoted by this symbol. The function small f is called the integrand, and the constant c is called the constant of integration. So when you write the capital F prime equal to small f, equivalently, you can also write the integral of small f equals capital F plus c. Because integration is the opposite operation of differentiation, we can use the rules for differentiation backwards when we take integration. So let's talk about some basic integration rules. Rule 1. The integral of a constant k is kx plus c. This can be easily verified by taking the derivative of kx plus c to get k on the left. Rule 2. When you integrate the x to the n, you get 1 over n plus 1 x to the n plus 1 plus c. This is called the power rule for integration. Again, if you take the derivative of the right-hand side, you get x to the n on the left side. Rule 3, if you take the integration of c times f, you can take out the c from the integral. Rule 4, if you integrate the sum or difference of two functions, you can always integrate each function separately and add or subtract them. Rule 5, the integral of e to the x is just the e to the x plus c. We know the derivative of e to the x is just the e to the x itself. Rule 6, if you integrate 1 over x, you get the natural log of absolute x plus c. We know the derivative of natural log of absolute x is 1 over x. So you can always check the formulas by taking the derivative on the right side to get the integrand on the left side. Let's do some simple examples. Find the indefinite integral of 1 plus x plus e to the x. So we got 3 terms in the integrand that we can break up into 3 integrals. In the first term, we get 1 to integrate. We get 1 times x because 1 is a constant. And in the second term, we can rewrite as x to the 1. So we can use the power rule to get 1 over 1 plus 1 times x to the 1 plus 1. The power rule says when you integrate the x to the n, you get 1 over n plus 1 times x to the n plus 1. So n equal to 1 here. In the third term, we just get e to the x. So at the end, we got x plus 1 half x squared plus e to the x plus c. Let's do another example. Find the indefinite integral of square root of x plus 3 over x minus 2 times e to the x. So again, we can break up this whole thing into 3 integrals and take out the constant from inside. At the same time, we can also rewrite the square root of x as x to the half and using the power rule to integrate it. So we get 1 over half plus 1 times x to the 1 half plus 1. So n equals half in here. And we got 3 times the natural log of absolute x from the second term and the negative 2e to the x from the third term. So at the end, we got 2/3 times x to 3 halves plus 3 times natural log of absolute x minus 2 times e to the x plus c. Let's talk about differential equations and the initial value problems. The question here is, given the derivative of a function, f prime, can we find the original function f? Or can we solve for f? This is called the differential equation. But when you integrate the function, you always introduce the arbitrary constant c. So you need another condition to fix this constant. and we call this other condition the initial condition. The differential equation and the initial condition together is called the initial value problem. So let's do one simple example. Find the function f if it is known that f prime equals 3x squared minus 4x plus 8, and f1 equal to 9. So we just integrate the f prime to get the 3 over 2 plus 1x to the 2 plus 1 from the first term, minus 4 over 1 plus 1 times x to the 1 plus 1x squared from the second term, plus 8x from the third term. So we get the x cubed minus 2x squared plus 8x plus c. Plugging 1 for x, we get 1 cubed minus 2 times 1 squared plus 8 times 1 plus c equal to 9. And we can easily solve for c to get a 2. And this is from the initial condition, by the way. So fx is equal to x cubed minus 2x squared plus 8x plus 2. So that's the end for today.